All right, let's look at the first example problem. Now, the problem says the current in a 2 millihenry inductor is given to be IL equals to 50t e to the minus 10t amps for t greater than or equals to 0. Now, the question is find the voltage across the inductor for t equals to 0 plus, and what is the power absorbed or delivered by the inductor at t equals to 50 milliseconds. So how do you begin? Well, the first thing we want to notice is that in this problem, what is given? In this problem, we see that we are given the I of t. Okay, I of t is given to be some value. Let's see, it's not a value, it's an expression, 50t e to the minus 10t amps. Let me make sure it is amps. Yes, it is amps for t greater than or equals to 0. Okay. Similarly, the inductance L value is given to be 2 millihenry. Okay. You see, this is how you begin any problem. Take stock of what is given. I of t is given and L is given. Now we can go back to the formulae that Sergio described earlier, and see that we can apply this formula. Because we are asked to find out V, we can simply use V equals to L di by dt. Okay. Now, so let's start using that. So in order to find A, okay, what we will do is we are supposed to find BL at time equals to 0 plus. So we can very well use V equals to L times di by dt. Okay, let us see where that gets us. The L value is given to be 200 millihenry. Okay, so I'm plugging in 2 into 10 to the negative 3. It's given to be 2 millihenry. Sorry, it's given to be 2 millihenry. So this is the L value. Let me even put 2 millihenry. Okay, this is milli right there, 10 to the negative 3. Okay, now d by dt of the current is what? 50 t e to the negative 10t. Okay, and this is in amps. So now it's a matter of just doing derivative. We have a composite function here. Okay, so we have to apply the chain rule. The rest is all constants. So I'm going to leave 2 into 10 to the negative 3 Henry as is. I'm going to factor out 50 because it is a constant. And by applying the chain rule, I have e to the negative 10t, that is the derivative of this guy, minus t times 10 e to the negative 10t. That's the chain rule of composite functions. Okay, so now what I can do is I can simply write it, multiply this 50 times 2, and then write out what I will get is 0.1 times e to the negative 10t multiplied by 1 minus 10t. So all I have done is to factor out this guy, e to the negative 10t common here. What is remaining is a 1 here, um, is a 1 over here, and then 10t from there. So all I have done is simple mathematical manipulations. Okay, but this guy is in what? In milli volts. Okay, or this is in actually volts. Okay, the voltage at time t is given by 0.1 e to the negative 10 times 1 minus 10t in volts. Now it's easy to solve problem A, where we are supposed to find voltage at time equals to 0 plus. I plug in 0 into the above equation. Let me do this first. Let me put this in a box so we can keep coming back to this equation. Okay, this expression. So I plug in t equals to 0 in each of the t terms over there. What I get is a 0.1, 0.1 into e to the negative 10 times 0, so that is e to the 0, into 1 minus 0, 1 minus 10t is 10 times 0. What we have is 0.1 volts, or that's 100 millivolts. Pretty straightforward problem. All I did is to look at what is given and which formula applies for the given variables and the unknowns. Okay, so in order to answer this question, V at time t equals to 0 plus is 100 millivolts. Okay, so that's number A. Now let's see if we can solve problem B as well. Problem B asks us to find the power absorbed or delivered by the inductor at time t equals to 50 milliseconds. So power absorbed or delivered at time t equals to 50 milliseconds. Okay, what do we know? We know that power, let's go back. Let's go back to our formulas. Okay, so we know that power can be obtained as a function of voltage and current. Do we already know the voltage? Yes, we did, because we calculated the expression for voltage. Okay. Similarly, the expression for current is given. That is the expression for current. So we have a an expression for voltage and current. All we have to do is to multiply voltage and current, and then plug in the value for t. So all I'm going to do is to, at p 50 milliseconds, I look at the voltage at 50 milliseconds, multiply that by the current at 50 milliseconds. Okay, so we can do that. The current, let's see the current at 50 milliseconds. I of t equals to 50 milliseconds is what? Is this expression, okay? This expression where t value is 50 milliseconds. Okay, so I'm going to plug in 50 t e to the minus 10 t amperes, and then into t I'm going to plug in 50 milliseconds. Okay, so what I get is 50 into 50 milliseconds into e to the minus 10 times 50 milliseconds. Okay, minus 10 times 50 milliseconds. So you calculate that, you'll get something like I of t equals to 50 milliseconds is going to be 1.516 amperes. Okay, so we calculated the current. Now it's a matter of calculating the voltage. Everybody with me so far? We are solving problem B. We started with an expression for current. We are given that. We are given a value for L, and then we derived an expression for VL as a function of time. Then we are multiplying the expression for V and I in order to get power. Pretty straightforward. Okay, so let's see. We are interested in finding V at t equals to 50 milliseconds. Okay, 50 milliseconds. I'm going to look at this equation, 0.1 times e to the minus 10t into 1 minus 10t. So in the place of t, all I'm going to do is to plug in the value of 50 milliseconds. Okay, So that gives me the value of voltage at time t equals to 50 milliseconds. So that is going to be 100 into e to the minus 10 times t, which is 50 milliseconds, multiplied by 1 minus 10t. T is what? Again, 50 milliseconds. Okay, so you expand this milli into 10 to the 3, you plug in all the numbers into your calculator, what you will see is voltage at t equals to 50 milliseconds is equals to 30.327 millivolts. Okay, why are we doing this? Why are we calculating the value of the voltage? That's because if I know the value of the voltage, okay, which is this guy, and the current, I can multiply them both. So the product of V at 50 milliseconds and current at 50 milliseconds gives me the power at 50 milliseconds, instantaneous power at 50 milliseconds. Okay, so the product of 1.516 amperes coming from here, okay, and 30.327 millivolts. So that's going to be around 45.985 milliwatt. Okay, so the power, therefore, we are looking at problem number B, the power at t equals to 50 milliseconds equals to 45.985 milliwatt. Does that answer the question completely? Not quite, okay? Because the question still asks us to calculate or to say whether this is power absorbed or delivered, okay? Pay attention to this. It says power absorbed or delivered. But we know from our previous chapters that because this is a positive power value, it is power absorbed. Therefore, the power absorbed by the inductor is 45.985 milliwatt, okay, at t equals to 50 milliseconds. To summarize, this is the kind of problem where the current expression is given and the inductance value is given. Okay, now we can use the L di by dt expression to solve for the voltage and power.